Hello students, welcome to all of you. Today we are going to learn about the mechanical properties of solid substances. So we start our lesson. Uh, you know about the rigid bodies. So rigid bodies, how can we define rigid bodies? Rigid bodies are actually the solid bodies. And these solid bodies, they maintain their shape and size against the external deforming forces. Means there will be a no effect of any external forces which tries to change its shape and size. Okay, means their molecular structure is such that the distance between the particles or molecules of solid, they do not change. Therefore it is called as the rigid bodies. And rigid bodies has different properties. I mean, solid substances have different properties, mechanical properties, especially solid objects are malleable, okay, they are brittle, uh, they are ductile. These are the physical properties, okay, and also they show elastic properties, plastic properties. So, among these properties, today we are going to focus on elasticity of the rigid bodies or solid bodies, right? Okay, now what happen when we stretch a rubber? Okay, uh, when we apply force on rubber, so the rubber gets elongated, and after removing the force, what happen? The rubber will again regain its original shape and size. So this property of materials uh, which regains their original shape and size after removal of deforming force is called as elasticity, and the materials are called as elastic materials. Okay, so elasticity means the substances which regain their original shape and size against after removal of deforming force. Deforming force is what? The external force. Actually it is an external force which tries to change the shape and size of the objects. Okay, and if we see in detail, then inside the elastic materials there will be an opposite force is generated when external force is applied or deforming force is applied on elastic materials. So there will be an equal and opposite restoring force is generated, which is equal in magnitude and opposite in direction. So restoring force tries to regain the original shape and size of objects, and this deforming force, suppose we denote it as Fd, which applies on rigid bodies. So there will be an equal and opposite restoring force is generated, and these forces are equal and opposite in magnitude, means there will be an equilibrium condition. Okay, so due to this the material gets its original shape and size. Okay, so elasticity, uh, how can we define elasticity? So elasticity is the property of a material. It is the tendency. We can define elasticity as it is the tendency of materials. It is the tendency of materials which regain their original shape and size. Original shape and size after removal of deforming force up to a certain limit, up to a certain limit. This is the definition of elastic materials. Now, elastic materials also oppose the change in shape and size. Okay, so we can define elasticity as it is an opposition. It will be a second definition. It is an opposition to opposition to change. It is an opposition to change in shape and size against deforming force. Deforming force. It is an opposition into change in shape and size against the external deforming force. We can understand with the help of example. Suppose steel is also an elastic material. So when we apply force, suppose we have a steel scale. Okay, so when we apply a force on a steel scale or strip, so it is in a vertical position. When you apply force, it bends, and when we remove force, it regains, it vibrates first and again comes to a original position. Means it opposes as compared to rubber gets easily stretched, but steel opposes its change in shape and size against the deforming force. Okay, so that's why uh, elasticity elasticity is also an opposition to change in shape and size. But one question comes in mind, uh, between rubber and steel, which material will be more elastic? We know rubber and steel both are elastic materials, but uh, how can we decide which one is more elastic? So we know that rubber gets elongated when apply when we apply deforming force, and after removing deforming force, it gets regain its original shape and size. Okay, but up to a certain limit. Okay, there is a limit, uh, and as well as when we apply deforming force on steel, then what happen? Steel resist. Okay, and it opposes against the deforming force. Okay, and when we remove deforming force, steel vibrates and very quickly as compared to rubber, it regains original shape and size. But when we apply excess force, then steel will get bent permanently. Okay, so with the help of these characteristics, steel will be more elastic because it regains its shape and size very fast as compared to rubber. Okay, we can understand elasticity with the help of example given in a textbook. Okay, so suppose we have these particles or molecules of solid or rigid body, and they are connected with the help of these springs. Okay, these springs represent intermolecular forces. intermolecular forces. Inside the solid material, the molecules or particles are at fixed positions. This distance between two molecules are fixed. Okay, and this structure is in equilibrium condition, right? Suppose when we displace, suppose any particle, suppose we just displace these particles to this position, then what happen? These springs, these springs attached with this particle or molecule get stretched, and they uh, tries to pull this displaced material towards its main position or original position. Means they apply a restoring force. We applied, what happened first, we displace this by applying deforming force, and these springs tries to pull back this molecule to its original position. So there will be a restoring force developed inside the rigid bodies. uh, we know spring, when we stretch the spring, what happens, string applies equal and opposite force. There is a restoring force is generated inside the spring. Okay, and when we remove the force, external force, this restoring force tries to regain its original shape and size of spring. When we compress the spring, so again the restoring force is generated, and after removing force, the string will get its original shape and size. Okay, so like that, these springs are actually the intermolecular forces. They tries to balance against the external deforming force. Means here deforming force will be equal to restoring force generated inside the solid materials. When this condition it becomes equal, so the molecules, this structure become in stable position. Means uh, this system has minimum potential energy. We know for a system to be stable, to be in stable condition, uh, it should have the minimum potential energy. We can understand with the help of potential energy versus displacement graph. So here potential energy versus distance r. So we get the graph like that. Here at this point, the potential energy will be minimum. So we denote this distance as r naught. This is the distance of the minimum potential energy. At this distance, this is the distance at which this molecular structure will be stable. So this r naught distance, we denote this distance between molecules as r naught. So this distance denotes that the system is in stable condition. So I hope that you will understand with the help of this graph. When we try to compress the solid materials, the potential energy will increase and vice versa. Okay, so we will see the next topic. Okay, now when we apply force on deforming force on solid materials, so stress is developed inside the solid materials. Stress is what? It is the ratio of restoring force per unit area. Restoring force generated per unit area in the solid material. Or we can say it also that it is a ratio of deforming force per unit area. But in major cases we denote it as a restoring force generated per unit area of the solid materials, and its unit will be Newton per meter square, and it's an scalar quantity, right? It's an scalar quantity. So stress means what? It is a type of condition, like suppose we have stress in our daily life. Okay, we have physical stress, mental stress. Okay, we say it as it's a type of क्या इसको कहेंगे, it's a खिंचाव खिंचाव या दबाव उसको कहेंगे. Okay, right. I hope that you will understand. Stress means दबाव और खिंचाव. Okay, suppose we take an example. Suppose we have a metal rod. This is a metal rod which is fixed at a rigid support at one end, and at the other end we try to pull it. Okay, we apply a deforming force. We try to stretch this metal rod. So this cross section is a unit cross sectional area inside the metal rod. The restoring force is developed. Okay, which tries to regain its original shape and size. This force is equal to this deforming force, right? Here deforming force will be equal to restoring force. So stress is developed inside the this metal rod, right? Now we will understand different types of stress depending upon the nature of application of force. Okay. So first type will be a longitudinal stress. There is two types again in longitudinal stress. Number one is tensile stress, and second one is compressive stress. So we take example, we have a metal rod. Okay, we apply deforming force like that along the length of this rod. So equal and opposite restoring force is generated inside this metal rod. This is the case of this tensile stress. And when we apply force on this metal rod, this external force tries to compress the metal rod. Then there will be an equal and opposite restoring force is generated. This is the example of compressive stress. Okay, force is applied along the length of metal rod, therefore it is type of a longitudinal stress. Okay, now second type is shear stress. So we can understand shear stress uh, with the help of example. Shear stress, it is nothing but the tangential force applied per unit area. We denote it as a ratio of sigma. This is the tangential force applied per unit area. Means we take an example of a thick, it's a long, it's a thick book. Okay, एक आप एग्जांपल लोगे, एक ऐसा जाली बुक है. ओके, राइट. तो अभी क्या होगा, व्हेन वी अप्लाई फोर्स एट द front, at the upper side of the textbook. Okay, what happen, the layers of textbook, the shape of textbook will change, right? Suppose we take example of cylinder. This is a cylinder or metal rod. What happen, when we apply force, this cylinder gets changed its shape. This is the tangential force, F tangential, applied tangent to the surface. Okay, so there will be a shifting of the upper surface. Suppose we denote it as delta x, and this will be a length of this cylinder. So the upper as compared to lower surface, upper surface will be shifted due to this tangential force. This is called as the shear stress, which tries to change the shape of the object. Okay, understand? Now we'll see the third type, volume stress. So volume stress, when we have a solid object material kept inside the liquid, and what happen? This liquid tries to compress the solid object inside the liquid. So there will be a deforming force per unit area on every point on this solid object, and this deforming force tries to compress or decrease the volume of the solid material inside the liquid. So it's a ratio of uh, deforming force per unit area, or we denote it as a pressure of liquid. Okay, pressure formula we know, force upon area. So we denote this type of stress as a liquid pressure. Okay, here there may be a pressure difference. Okay, right? Inside pressure will be something, outside pressure will be greater. Okay, so there is a change in pressure. Okay, so this will be the case of uh, compressive stress. Okay, so we call it as a liquid pressure or volume stress, right? Now we will understand about the strain. Strain can be defined as change in dimension per unit original dimension of material. It is the ratio of change in dimension upon original dimension. So it's an effect of deforming force. What happened when we apply force on material, solid materials? They come under the stress. Okay, and as a result, there will be a change in shape and size of the materials. So it's an effect of stress. Okay, more will be the external force applied, more will be the change in length. Suppose we have metal rod, when we apply force on metal rod, its length will increases. So this will be the change in dimension per unit original dimension, right? Okay, suppose we have a metal rod. This metal rod is fixed at rigid support. We apply deforming force. So what happened? Its length changes. So this will be a change in length. This is the delta L change in length. This is the original length. So the strain will be a change in length per unit original length. Change in length per unit original length. This is the strain, right? So again there are three types of strain also. Okay, we will see one by one. So first type is longitudinal strain. Longitudinal strain. So we have metal rod. here when we apply force again along the length of this metal rod, so there will be a change in length. So it will be a ratio of change in length per unit original length. This is the longitudinal strain. Okay, here length of the rod changes, right, when we apply external force. This is the deforming force which tries to change the shape of this metal rod, right. Now second type is shear strain. Now shear strain, we have a solid cylinder. Okay, when we apply force, tangential force at this upper surface, then this upper surface shifts. At the base there will be a no shifting of the lower surface, but due to tangential force there will be a slight displacement of the upper surface. So this will be our original length and this will be the displacement of the upper surface. There is an angle theta is formed. Okay, so shear strain will be a ratio of delta x upon L. Now we when we take a tan ratio, so it is also equal to tan theta equal to delta x upon L. But this tangential force, due to this tangential force, there will be this shifting of the upper surface. Delta x will be very small. Okay, means this angle theta is very small. So we know that when theta is very small, so tan theta or sin theta will be equal to theta. Okay, so we denote this ratio as theta equal to delta x upon L. This is the shear strain, right. Now number third is, one is volume strain. Number three is volume strain. So this will be a ratio of change in volume upon original volume. Change in volume upon original volume. We take an example of solid material kept inside the liquid. So liquid tries to compress these solid objects. There will be a force on each and every point of the solid materials normal to the surface of this solid material. So there will be a pressure. Okay, these solid materials uh, strain is developed. Okay, means its volume is reduced due to this pressure of liquid. Okay, suppose inside pressure will be P naught and outside pressure will be P. So there will be a change in pressure P naught minus P. There is a pressure difference. Okay, so change in volume upon original volume, it is the ratio of change in volume upon original volume. So this is the volume strain. Okay, now here we will stop, and in the next lecture we will see about the modulus of elasticity and its a type. Okay, thank you very much.